Hello. Uh, I just realized I had been having some connection issues with my previous broadcast, uh, which is unfortunate. I haven't looked at it yet. I don't know what was all missed, which is kind of a bummer. I was having a lot of fun in Skyrim, figuring out the sky. Um, yeah, I must have had some weird connection issues. It kept dropping. I was checking Twitch, and I've got like 3 different videos because I guess it dropped and then reconnected. Um, Whoops. Uh, haven't seen that happen to me before. Um, so maybe just a quick recap of what I discovered about the sky of Skyrim. Uh, First, the sun does rise in the east, set in the west, just like it does here on Earth. I did notice it seemed to go straight overhead, though, from east to west. That indicated to me that the location, the map, has somewhere really near the equator, if not on the equator of this world. I also noticed at night there was some object that appeared to move west to east through the sky, and it cast its light uh, bright enough that we could see a shadow, and it would move in the opposite direction than like our shadow during the day when the sun was going overhead. Um, Now, the math is a bit wonky because based on the shadow at least, it seemed like it went from like overhead to about 45 degrees in about 4 hours. So we go from like overhead to horizon in like 6 hours. But now that I think about it, because it popped up again the exact same time the next night when I was kind of like fast traveling or the waiting. So my estimates might have been off. Probably took about 6 hours then, not 8 hours, to go from overhead to horizon. So it's just the sun goes overhead and then something rises and goes the other way during the sky. And then the sun comes up and then something else comes up, goes west to east. Okay, so that's a lot easier. So if I'm here and it's overhead, by the time I move 6 hours here, it appears to be over here. So it went half of the orbit in 6 hours. That means it takes about 12 hours to orbit. Yeah, 12 hours to orbit. That's crazy. 12 hours to orbit. So then I was going to try to figure out if we were to assume the planet underneath us is Earth-like, has about the same mass as the Earth. We're going to have to assume the same size, because as far as I can tell, we're not going to be doing a lot of astronomy to figure out the size of the planet that we're on. Historically, we've done that by looking at shadows cast by objects, shadows from the sun, 2 different locations on Earth, like north and south difference, and then we look at the difference in the angle of the sun at the same time of day. That can tell us, like, if the classic is during the Greek era. What was the dude? I want to say Eratosthenes, but I might be getting my Greek guys mixed up. The trick was he knew that at the solstice in one place, the sun's light would hit the bottom of a well perfectly, and then all you had to do was somewhere else, maybe like farther north, farther south, you measure shadow at the same time at the solstice. So one place it's like vertical shadow, and another place you're going to have a little bit of a shadow, and that is enough to figure out the curve of the Earth with some tricky geometry. I don't think we're going to be able to do something like that in this game. Be a bit tricky, and I don't have any GPS to work with. I'm already kind of at a stopping point. We're trying to figure out how we know it's going around in 12 hours. Don't know how far away it is. Couldn't see it in the sky. And yeah, we don't know how far away it is. Therefore, we don't know how fast it's going. But let's see if we can do this. The speed that it's orbiting is going to be the circumference. This is maybe how we could do this. Because the circumference of the orbit is 2 pi r. And the speed at which it's traveling is going to have to be that distance divided by the time, right? So speed is distance over time, and the distance is the circumference, because we're doing an orbital velocity. We're assuming a circular orbit. It's going to have to be the assumption we're going to have to go with. So that means we could swap in, and the circumference is just 2 pi r. So for the speed, we could substitute, if I'm doing this right, 2 pi r. That's the speed, equals 2 pi r t. T is t. R's cancel out, so we're going to have, and the 2 pi cancels out. Wait. We don't want the R to cancel out. I might have been doing the equation. I think I've been doing the equation. Think a little too hard about this. Probably because it's also 1 a.m. Probably need to get some sleep. No, it's because I'm making the wrong assumption about the orbital speed. We already have the equation for orbital speed. Can't be introducing the other thing. That's just bonkers. Yeah, what am I doing? It's already is, oh. Hello. We could use our good friend Kepler's third law. Yeah, this might be beyond my brain right now at 1 a.m. That's the one I'm thinking about. I got to take a bathroom break too. It's probably another thing that's influenced my brain. Trying to, I feel like I've done these calculations before. It's just I'm drawing a blank. Anyway, pretty exciting. Whatever is orbiting the world of Skyrim, it's orbiting every 12 hours. That is ridiculously fast, considering our own moon orbits, every 29 days. Well, I guess it depends. 27, 29 depends on where you're tracking it from. I'm going to take a quick bathroom break, and then we can finish the math here.